Dear students, welcome to the third session of our Chapter 8 Redox Reactions. In this session, we will learn how to balance the chemical redox reactions. There are two methods to balance the chemical equation for a redox process. One of them is based on the change in the oxidation number of a reducing agent as well as the oxidizing agent. That is said to be oxidation number method. And the other one is based on the splitting of the redox reaction into two half reactions, one involving oxidation and the other involving reduction, which is named as half reaction method. So with these two methods, we have to learn how to balance the redox reaction. Now let's see the first type of balancing, that is oxidation number method in acidic medium. With a problem, we can understand the steps. There are 5 steps with which we have to balance the ionic equation or the chemical reaction in acid medium. Right? Let's see the question. That is, write the net ionic equation for the reaction of potassium dichromate, that is K2Cr2O7. In this formula, the chromium is having a +6 oxidation state. That's why the Roman numeral 6 is mentioned there. With sodium sulfide, that is Na2SO3, in an acid solution to give what? Chromium 3 ion. That means in the product side, the chromium will be changed to +3 oxidation state, and along with that the sulfate ion is there. So this is our question. The first step is to write the skeletal ionic equation. Now what is this skeletal equation is? We are removing the positive part of the reactants, that is potassium and sodium ions, and the remaining part we are writing. So what happens is it becomes Cr2O7 2 minus dichromate ion plus SO3 2 minus ion sulfite ion. It gives you what? In the question itself it is mentioned that chromium 3 ion. So Cr3 plus ion plus sulfate ion, that is SO4 2 minus ion. So this is our skeletal or ionic equation. The first step is complete. Now the second part is what? To assign the oxidation number for the chromium and sulfur. In all the reaction, you have to write each and every atom's oxidation state. Now here in this, we have mentioned to write the oxidation number of chromium and sulfur. Why? Because oxygen is getting the same oxidation number for all the cases. Now, when you assign the oxidation number, how we have to do the step is, the second step also, the first step, how you have written the equation, you have to write it again, and then above the each atom, you have to write the oxidation state. So Cr2O7 2 minus, when it is written dichromate ion here, above the Cr, the +6 is mentioned. That is, chromium is in its +6 oxidation state. Oxygen -2. Then sulfite ion, S is in +4 oxidation state and oxygen -2. The next one, product side, we can see that Cr3 plus is there, so that means its oxidation state will be +3. Sulfate ion, SO4 2 minus, oxygen -2, sulfur +6. Now we know that how to find out the oxidation number of each and every atom. We have learned in the last session. That is, if we want to find out the chromium ions oxidation state, which is coming as +6, how we are doing? You have to put here X, but here Cr2 is there. That means you have to put 2x plus 7 into 2 minus 2 is equal to -2. When you solve it, you will get what? +6. So this way we have done for sulfur also. And what about this? We have to see that what change is there in the oxidation number. Now, in this oxidation state, when you are aside, what we can understand? The dichromate ion is the oxidant and sulfite ion is the reductant. With this, we can understand where the oxidation has been taken place and where the reduction has been taken place. We have learned the definition for for oxidation and reduction as what? In terms of oxidation number. When there is an increase in oxidation number, oxidation. When there is a decrease in oxidation number, that is reduction. So here +6 to +3, there's a decrease. Then sulfur plus 4 to plus 6. That means there's a increase in oxidation number. So it is what increase in oxidation number is oxidation. And the other one chromium is what reduction part. The third step is to calculate the increase and decrease of oxidation number, and then we have to make them equal. After balancing the oxidation number, we have to balance the atoms on both the sides. Now, in this equation, in this general equation, Cr2 minus plus SO3 2 minus giving Cr3 plus SO4 2 minus, as we have seen that chromium was in plus 6 and it changed to plus 3. That means there is a decrease of 3 oxidation number. To make it balance, how we can do is we can put a 2 numeral in the right side. So it becomes what? 2Cr3 plus. Then what about the sulfur? Plus 4 to plus 6. And the change is for plus 2. That means plus 2 oxidation state change is there. So we have to put a 3 oxidation, 3 numeral on the right side of sulfur. That means the 2 and 3 were the change in oxidation states. So the chromium, how many? 3. And that should go with sulfur. And what about the sulfur? It was 4 plus 2 oxidation change. Increase was there. So it goes with chromium. Now, after this, we have to see that both the side the atoms are balanced or not. The chromium here 2 is there, and right left side also 2 is there. So it is balanced. But what about the sulfur? Sulfur 3 is on the right hand side. So we have to put the 3 coefficients on the left hand side also for the sulfite ion. So it becomes now balanced. After this step, the fourth step is what? As the reaction occurs in acidic medium, we have to change the ionic charges further. That is, when it is not equal. Now what we have to do is add 8H plus on the left hand side to make the ionic charges equal. Left hand side, when you put the plus 8H plus ions to make the charges equal. When you see the total charge, overall charge, when we are calculating for the left hand side and the right hand side, we can understand that how many charges are uh, equal or not, we have to understand. And with that, we can understand that the charge is less on the left hand side, and we have to add what? 8H plus on the left side to make the ionic charges equal. As we have said that 8H plus should be added to left hand side to balance the ionic charges on both the sides. How we are calculating is we have to see that what charge is there on the left side, add up all the charges, add it, and then on the left side, right side also you have to add. But here the deficiency of what? 8 plus charge is there. That is, to balance the 8 plus charge or the ionic charge, we are adding 8H plus ion on the left side. As the left side it was 10 and the right side it was 18. So the less of 8 is balanced by 8H plus ion. And the last step is we have to count the hydrogen atoms here and add appropriate number of water molecules on the right hand side to balance the redox reaction. Now you can see here the left side only that 8 plus ion is there. 8H plus ion is there. To balance the 8H plus ion, we have to add what? 4 water molecules. Why? Because here the H is coming 8. 4H2O. That means 8H plus ion is there on the right side. Now it is getting balanced. So this is the final step to balance the redox reaction in acidic medium in oxidation number method. So what are the steps? The first step is to write the skeletal equation. Second step, assign the oxidation number for each and every atom. Third step, we have to see the increase and decrease of oxidation number, and then we have to balance them. After that, we have to see both the sides what the atoms are getting balanced or not. If it is not, we have to balance. The fourth step is what? We have to see the ionic charges on both the sides of the equation, that is the reactant side and the product side. The ionic charges should be equal. If it is not equal, we have to balance with H plus ion. H plus ion is added to the deficient side. And then finally what we have to check, we have to see the how many hydrogens are there, hydrogen atoms are there. If it is not balanced, you have to balance with water molecule according to the hydrogen ion or hydrogen present on the reaction, present on the left side or the right side. We have to balance that with water molecule. And finally we are getting the redox reaction in acidic medium through oxidation number method. Next, we have to see the oxidation number method in basic medium. Let's see with the other example, that is permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ion. Write the balanced ionic equation for the reaction. Now here when we are having permanganate, that is potassium permanganate, when you dissociate you will get what? MnO4 minus. KMnO4 is the potassium permanganate. So dissociate it, you will get what? MnO4 minus plus bromide ion. Bromide ion is Br minus, giving MnO2 manganese dioxide plus bromate ion. Bromate ion is BrO3 minus. Now this is our ionic equation, the first step. The second step is to assign the oxidation number for manganese and bromine. Right? Oxygen is -2. So we will get what? MnO4 minus. What is the oxidation state of Mn? When you put X, you will get what? X plus 4 into -2 is equal to -1. You will get the oxidation state of manganese as +7. And bromide ion is -1 here. That means it is -1. MnO2, you will get what? X plus 2 into -2 is equal to 0. You will get X as +4. So Mn is +4. Bromate ion, bromate how? X plus 3 into -2 is equal to -1. You will get +5 oxidation state. And this indicates that permanganate ion is the oxidant and bromide ion is the reductant. That is, the change is +7 to +4. That is decrease in oxidation state. Then what about bromide? Bromide to bromate, it is -1 to +5. That is, there's a increase in oxidation state. So these are the oxidation states when we understand through this reaction. That means oxidation and reduction has taken place. Only the thing is we have to see the change. That is what is the increase or decrease of oxidation number is there in each oxidation and reduction part. When we see +7 to +4, what is the decrease? +3 oxidation state. What about the other case, that is from bromide -1 to +5? There's a change of +6 oxidation state or increase is there for bromide to bromate ion. Now let's see the third step, that is to balance the oxidation number that we have to do with the thing. That is, we know that how to balance it. When you balance the oxidation state, you have to put what? Uh, two coefficient for the manganese side, MnO2 side. When you balance it with 2 coefficient, what we will get? You will get what? 2 MnO4 minus plus Br minus, giving 2 MnO2 plus BrO3 minus. How we have balanced it? We have to see that all the atoms are balanced on the right side and on the left side. 2 Mn, 2 Mn. Now what about the bromine? 1 bromine, 1 bromine. So it is getting balanced. So you don't have to do the further addition. Now step 4 is what? As the reaction occurs in basic medium, the ionic charges are not equal on both sides. Then we have to add 2 OH minus ions. Before in the acidic medium we have added H plus ions. Here we have to add 2 OH minus ions on the OH minus ions on the right side to make the ionic charges equal. So as we check, we can understand the right side, the deficiency of 2 ionic charges is there, and to balance it we have to put 2 OH minus. Okay, then the equation changes to 2 MnO4 minus plus Br minus, giving 2 MnO2 plus BrO3 minus plus 2 OH minus. Finally what we getting is we have to see the hydrogen atoms. We have to see or we have to check for how many hydrogen atoms are there on the left and the right side. Then add appropriate number of water molecules to the deficient side to balance it. Now here when we are seeing the hydrogen atom, where the hydrogen atom comes along with the OH. So how many is there? 2. When 2 hydrogen is there, how many water molecule we will add? Only 1 molecule. Why? Because in this the 2 hydrogen is coming. So 1 molecule of water we are adding, and finally we are getting the redox reaction as 2MnO4 minus plus Br minus plus H2O, giving 2MnO2 plus BrO3 minus plus 2OH minus. This is how the redox reaction we are balancing in basic medium. So what are the steps again? Acidic and basic medium, both the cases, the third step, up to the third step, it is equal. That is skeletal equation you have to write, assign the oxidation state, then calculate the increase and decrease of oxidation number, and then we have to balance it on both the sides. The fourth step, when it is acidic, we have to add the H plus ion. When it is basic, we have to add OH minus ion. And the last step is again same. That is, when we have to count the hydrogen atoms, where the deficiency is there, there we have to add water molecule. So this is the balancing of redox reaction in acidic as well as basic medium. Thank you. We'll continue in the next session.